So, I just hit record. I'm going to be a little bit late. So, when you're doing U substitution, you're very much trying to look for, do you see a function in which the derivative of that function, that g prime of x, is also part of the function, okay? So when I look at, say, this example, I see this x to the fourth, and I see 4x to the third. Are you guys with me that somehow that 4x to the third might be related to as a derivative of that x to the fourth? Okay, so, and then typically, so we're going to go ahead and rewrite this. We're going to say u is equal to, and what I'm going to choose is that inside function of 2 plus x to the fourth. Because constants can kind of go in either direction here, okay? And if I tell you that u is equal to 2 plus x to the fourth, if I asked you to take the derivative of this with respect to x, what would we get? Du dx equals, what's the derivative of 2? 0, so I'm going to ignore it. Plus, and then I'll take the derivative of that x to the fourth becomes 4x cubed. And if I wanted to write this as a differential equation, we would just say du is equal to 4x to the third dx. All right, so the 4x to the third and the dx, I'm now allowed to replace. Because what do I know those are equal to? They're equal to du. All right, now, what am I going to replace the 2 plus x to the fourth with? U. So this will be square root of u. Is this okay? The hardest part about this is going to be deciding what do we use for u. So now I'm going to rewrite this as the integral of u to the 1/2 du. Okay? What's the integral of u to the 1/2? 2/3 u to the 3/2 power plus c. But wait a minute. What's u again? Since our original function was in terms of x, we're going to write that integral in terms of x. We're subs that. So you're going to sub the variable out, the expression out, to make the integration easier, and then sub it back in. All right. How is this one different?
There's no 4 with a coefficient.
This is just an x cubed dx, yeah? Okay, so strategy-wise is going to be very similar. We're still going to let u equal 2 plus x to the fourth. Okay, we are still going to have that du equals 4x to the third dx. Now, can I replace x to the third dx with du? Because that du doesn't equal x to the third dx. So what we're going to do is kind of divide both sides over here by 4, okay? So that what I have on this side is x to the third dx, and what I have on this side is du over 4. So what am I allowed to replace that x to the third dx with? Du over 4. Now, with integrals, you can kind of take that constant and write it in the front instead. Now, that integral for u to the 1/2 is still going to be 2/3 u to the 3/2. And then we can simplify this to 1/6. And I'm going to replace that u back with the 2 x to the 4th to the 3/2 power. Let's see. So that 1/4 times 2/3, that's where that 1/6 came from. And then I just put the u back in. Is this familiar? So far, are these examples pretty decent? And everything else is just going to be slightly more complicated versions of this. Okay, so let's look at, say this one. What would you like me to use for you?
X to the 5th plus 6.
X to the 5th plus 6. And Owen, why did you say x to the 5th plus 6?
Because it's the thing in the parentheses.
Okay, so that's like the inside function. Okay, the other thing I want to jump out at you, because at times it's going to be a little bit more complex than that. Are you guys with me that x to the 4th is going to be very similar to the derivative of x to the 5th? Well, not equal to it, it's going to be similar enough that I'll be able to use it. So really, we're kind of looking for two pieces. We're looking for an inside function, but we're also looking for where do we have a derivative. Okay? All right, so what's du? 5x to the 4th dx. We want just plain x to the 4th dx, so we're going to divide by 5. So I might write this as take that divide by 5 and write it as a 1/5 in front. Then we'll have u to the 9th du. Help me out. How do I integrate what u to the 9th?
1/10 u to the 10th.
So what will we write this as 1/50 times x to the 5th plus 6 to the 10th plus c. How could we check this answer?
Take the derivative.
Let's do that real quick. What if I ask you guys to take the derivative of this? Everybody with me? Let's see. First thing I would do is 10 times this and bring it down by 1, right? So 10/50 times x to the 5th plus 6 to the 9th, right? Times the derivative of that inside function, right? Which would be 5x to the 4th. Does it feel good? Guys, 10/50 is 1/5, right? Times 5 would cancel out, so I would be left with just x to the 4th times x to the 5th plus 6 to the 9th. That c would go away. So did this work out to our original function? Okay, so I know I did it right. Yeah,
Can we get more room than this on the 10th?
yes. Thoughts?
same as cosine of x quantity cubed.
Yeah. That would be the first thing I would look at, is that's what that really means, yeah? And do we see anything where I take the derivative of one function, I get the other, sort of? So what should we set our u to be this time? Cosine of x, cool. I'm fine with that. What does that make du? Negative sine x dx. Which we kind of have, right? Other than the negative. So can we say negative du equals positive sine x dx? So I'll throw that negative out front. I'll let you guys take it from here. How'd I do? This one probably starts to stretch a little bit. Any thoughts? Okay. I agree that that's a great first step. That's what I would do first. Then what would you guys do?
Sine x times 1 over cosine x. Would that help you?
If we wanted to, I'm going to maybe write that in the other order. 1 over cosine x times the sine of x. Only because I know what the next step is, but it's the same idea. Okay.
Oh. Cosine x to the negative what? Right?
I wouldn't do that. You're going to run into,
Hard things.
well, if you did that, then you maybe let u equal cosine x, right? The integral of u to the negative 1 isn't necessarily what I would want to do.
Yeah.
Okay. How do you guys feel about me saying u is equal to cosine x, though? And can we say that? And if u is equal to the cosine of x, we can then say du is equal to negative sine x dx. We still feeling okay? And then, you guys, can I just move that negative over? Is that okay? Like we did last time. So now I have negative integral of 1 over u du. What is the integral of 1 over u? Another way of saying that, y'all, is what function has a derivative that is 1 over u? It's going to be the natural log of the absolute value of u.
plus C.
So if I want to find the integral of tangent, it is the negative natural log of the cosine of x plus c. It's possible that will pop back up eventually. How are we feeling? On a scale of like, thumbs down is terrible, thumbs in the middle. Okay. Cool.
It just weird. Does it smell like quesadillas?
I don't smell quesadillas.
I do not.
It's just me.
It is just you. Have you eaten a quesadilla?
I have not.
Have you worn that mask whilst eating a quesadilla?
I have not.
Are you sure?
I'm positive.
Quesadillas are what I like to call a grilled cheese.
Yeah.
Because that's what they essentially are, right? Grilled cheese only with a tortilla.
Right.
Right on.
Traditional grilled cheese. I've not had a grilled cheese in a while.
Me neither.
They used to be my favorite food, but they aren't enough, so I never make it.
Just make more.
You guys, I'm flying blind. I have not worked this question yet. So this should be pretty fun, right?
Great. Do you know where you're going with that though?
Nope, not at all.
Oh, great.
Oh.
Yeah.
I do know where I'm going to go with this. I don't think you guys are going to really appreciate this one for how beautiful it is, but that's okay.
Let's say you're gonna multiply me by that.
Would anybody like to just, let's do something, right? Any ideas? Yeah?
I think it'll be effective because later on it will be multiplied by the square root of like x plus 1 because the roots in the denominator, the 2x plus 1, and then on top the x times square root of x plus 1.
So you're saying write it as x square root of x plus 1 over x plus 1.
So I feel like that would complicate it a lot. So
It's not the choice I would make, yeah.
X times. No. I guess you could do x times quantity x plus 1 to the negative 1/2. But that's not
we
ideal.
need to make the top like so if we take derivative of x plus 1, like it needs to resolve or equal in that fashion.
You guys, can we say, let's go ahead and say u is equal to x plus 1. Are we comfortable with that?
Yeah.
All right.
I had
Now.
like a burrito for lunch. I don't think it's that fragrant.
There's something else I want us to see here that I don't think is obvious, okay? But if I tell you that u is equal to x plus 1, how would you guys feel if I also said then that that means x is equal to u minus 1? Is that okay?
Yeah.
I see what you're gonna do with this. I don't like it.
All right. And the minute we do that, let's go ahead and find du. Are you guys cool with me saying du is equal to dx? All right. So if we go through and we do some of these substitutions now, what can I substitute in for x? So the numerator becomes u minus 1. The denominator becomes the square root of x. And then the dx becomes a du. Hold on. Not the square root of x, the square root of u. Sorry, I misspoke. Are we feeling okay with this idea? And here's what this does that we didn't have before. I have a much simpler denominator, and I am allowed to split this up into like u over square root of u minus 1 over square root of u du. So, why is that helpful? Can we simplify u over square root u? Because this is like u to the 1, right? And that square root u is u to the 1/2. So all of a sudden I can just subtract my exponents there and say I'm integrating u to the 1/2 minus u to the negative 1/2 du. I'll let you guys look at that. So it's beneficial to take that numerator and turn it into two terms and that denominator to make it one simple term. Because now I can split it up into those two fractions. Like that's the intent of doing that. So now, what's the integral of u to the 1/2? Well, we've done it several times today now. It's 2/3 u to the 3/2. What's the integral of u to the negative 1/2? See, if I take that negative 1/2 and I add 1 to it, I get u to, and then I divide by that exponent, which really just means reciprocate the exponent. So switching out so sometimes it just helps to kind of like switch our variables out a little bit. And then my final answer would be 2/3 times x plus 1 to the 3/2 minus 2 times x plus 1 to the 1/2 plus c. Are we feeling okay? So for right now, let's have you guys practice numbers 1, 2, and 4 in your new homework packet.